To write a compound inequality describing the shaded region of this figure, I want to think about a single inequality that describes the relationship between the shaded region and each of the lines that make up the quadrilateral. So as an example, if I look at the left-hand side of the quadrilateral right here, the right-hand side of that line is shaded, and it's a vertical line, and that tells me that my values of A for that particular line must be greater than 10. Similarly, if I look at the right-hand side over here, this is also a vertical line. The quadrilateral is shaded to the left of this. This tells me that A has to be less than 70, and both of these things have to be true at the same time. So A is greater than 10, and A is less than 70. Could be simplified to this: A is greater than 10, which must be less than 70. If I do the same thing for the slanted sides of the quadrilateral, let's look at the top one first. I know that I need to shade underneath that line. And if I'm shading under the line that's set up as h equals, this means that my values of h must be less than whatever that line is, 0.8 times 220 minus a. Similarly, if I look at the very bottom of the quadrilateral, I have to shade above that. So there my values of h must be greater than whatever describes that line, 0.7 times 220 minus a. And just like before, I can write both of these inequalities using a single inequality. 0.7 times 200 minus a must be less than h, which must be less than 0.8 220 minus a. Ran out of room. And those two compound inequalities together will describe the shaded region.